A solution like this is the exception, not the rule. In fact, the previous example had 30 cameras simulated in order to monitor those traffic patterns. The reality is that you will be working with multiple cameras feeding into your device, and there will be a more complex pipeline on how the data coming from those cameras is being processed. This pipeline will result in decisions being made locally that may affect where the data resides, whether you store it locally or you send it to the cloud, or whether you actually process the data with multiple models. It is this interaction, the local processing that is happening on the device, as well as the communication to the cloud, what we will now be discussing. We call that live video analytics. Live video analytics is a new capabilities in Azure Media Services that allow you to build applications to analyze video. These capabilities span the cloud and the edge and enable you to use IP cameras for more than just security and surveillance. Live video analytics on the edge is today in public preview and is delivered as a single container that runs in either x64 or ARM64 systems, delivering you this pipeline management functionality and the definition of topological maps for your media needs. There is also a version of live video analytics that is available in private preview in the cloud today, where you have a REST API that is part of Azure Media Services. So let us have a look at how live video analytics works. What you're seeing here is a diagram of live video analytics. The red box right here illustrates the container. This container is capable of capturing data from multiple sources, whether they're regular IP cameras or even existing brownfield cameras. These cameras produce the information that is captured by live video analytics, and it can be analyzed with modules that you bring. Live video analytics itself has a motion detection model, but you can build your own detectors. And in fact, I'll show you how to do that in a few. When you have performed the inferencing, you can actually publish the results of those either to a local business logic solution or all the way to the cloud, when you can do further processing, archival, or continue to execute on top of it. Live video analytics' goal is to make it easy for you to define topologies that leverage advanced AI capabilities on top of traditional video feeds and brand new IP camera feeds that you might be integrating into your solutions. No better way to see this than through a demo. So let's look at the LVA demo. The LVA demo will provide us again with object detection, and it will also take data that is processed locally and send it to the cloud for archival. We have already seen how this operates in the past. We have deployed in our system an NVIDIA DeepStream container. So what we're going to do now is we're going to bring that container from LVA, and that container is going to be deployed onto our Mariner Linux VM. It will be able to leverage a DeepStream container that we have running inside of it, and through that, process the information to send it back for archival on media services on the cloud. Nothing better than a demo to show you how it works. So let's look at it. So for our demo, we're going to start by going back into our system and opening a new Visual Studio Code. As you can see, we have a new template to deploy these modules. Here's the LVA Edge module that I was mentioning. That LVA Edge module has our video analytics container image. We have a simulator for RTSP that will actually be feeding the signal into our containers. And we have this LVA extension component. This is a brand new DeepStream container that will actually be performing inferencing on top of this video feed. All three containers will be deployed using IoT Hub. So let's generate the manifest as last time. We're generating the deployment manifest. Now that we have the deployment manifest generated, we can go and deploy it to a single device. We're going to go again to NVIDIA eFlow. And the deployment succeeded. As you can see, our previous containers are going to be refreshed now, and the modules are scheduled to be deployed. Both LVH, RTSP, SIM, and LVA extension are running here. We can now go and activate that platform through a Cloud Device Console application. What this application does is that it will interact with that container and it will set up a topology. We will do that interaction through this file, the operations.json file. So let's look at the operations.json file so that we can see what operations we will be performing. Here in operations.json, we can see that we have a graph topology set that is going to be setting a graph instance, and that graph instance is the basis of our topology. We're going to call that the sample graph 1. Then we will activate that graph instance. We will wait for input so that we can illustrate what's happening, and then we will clean after ourselves. Let's look at the gRPC extension.json that defines that graph topology. We have that inferencing topology here, and it will be recording on motion to an AMS asset, and other events will be recorded through the gRPC extension for Hub. So first path is to take that RTSP source as a source and then process it. We have a first processor that is just a media graph motion detection processor, which is a simple motion detector that we're running on top of that feed. Then we have that additional media graph gRPC extension that is calling on that brand new module that is going to be doing the inferencing using DeepStream. That will take into input the results of motion detection so that we only process the images where motion has been detected, since we are probably looking at images from the highways. Then there's the sinks, places where we will be storing data, and you can see that we'll be storing it with a particular format. We will be sending them to the cloud and also sending those messages here to IoT Hub. So let's look at our NVIDIA eFlow module device. Let's look at our NVIDIA eFlow device, and we will actually start monitoring for events inside of it. You can see that the IoT Hub is already providing us with input. We can go and see that the modules are running. Next step is then to go and activate the topology and load it. So here we go into the topology. We are gonna run this topology and hit play. As you can see, we're running the topology. The topology has been identified, and it is pausing for us to continue. We activate that topology, and we start to see already the results of the inferences coming up into the IoT Hub. But remember that this pipeline was actually generating inferences on top of the images that are being detected. So let's actually open a web interface for that interface that is being defined by the gRPC extension. And that is that sample graph stream here. We have an MJPEG stream that is going to be showing us the result of those inferences. And you can see there the results, the cars are being classified. But that's not all that is happening. As the cars are being classified, we're actually sending those images to the cloud. So let's go to our portal and look in the portal into the media services, and we can see our assets there. We can see in the assets that a bunch of assets are being stored by the format that we had defined, and we can in fact look at one of those assets. I'm going to just create a stream of that asset to see what are the segments that are being stored, and you can see that there are the segments where motion is being detected that are being stored on the cloud. So the solution is functioning. We're grabbing all of these images, doing the detection, and also sending a copy of those images into the cloud. Now we can come back and see that the IoT messages are also being sent. Here's our inferences, for instance. This is a location of a white car in the image that has been detected. So all of the inferences are also being processed and sent to the cloud. Let us recap what we have seen so far. LVA allows you to build complex topologies that are run in the edge or in the cloud, full of rich, complex interactions that leverage AI inferencing modules that take advantage of full hardware acceleration. This enables solution builders to build true video solutions in a multitude of use cases, from transportation and healthcare to public safety, retail, manufacturing, and infrastructure. We can't wait to see what type of solutions you're going to build with LVA. This functionality is also in public preview and available at this location. We hope to get your feedback. But our